Let's solve this question, LeetCode875, Koko eating bananas. So for this question, Koko loves to eat bananas. There are n piles of bananas. The ice pile contains piles I bananas. So the girls have gone and will come back in each hour. So Koko can decide her banana per hour eating speed of K. Each hour, she chooses some pile of banana and eat K bananas from that pile. If the pile has less than K banana, she eats all of them instead and will not eat any more banana during this hour. So Koko like to eat slowly but still want to finish eating all the banana before the guards return. So what this part mean? This part actually means that here means that Koko likes to eat slowly but still want to finish eating all the bananas before the guards return. So here's the example. The piles can be 3, 6, 7, 11. H is the hours of the guard came back within each hour. That means that Koko want to eat slow but still want to finish eating all the bananas here within each hour, within 8 hours. So yeah, that's the problem. So so we're gonna return the minimum integer k such that she can eat all the banana with each hour. Yeah. So this is basically the problem. So for this question, we can use actually the straightforward method like brute force algorithm. Okay, so we can use this one. So if we use brute force algorithm, how do we do this problem? Let's try to copy this to here, and then so let's see the k, the speed of the Koko eating banana per hour. The eating speed is k. So we use the brute force. So the minimum number of k can be 0. No, can be 1. We cannot be 0. 0 means Koko don't eat anything, right? So at least eat 1 banana per hour. That's kind of the k, right? And then what's the max value of k? The max value of k, it could be what? So it could be the max value of k. It could be probably it's gonna be whatever the max in our input array is. So for this one, the piles. So the piles, we have a 4 pile, 1, 2, 3, 4. So the max value of a pile is 11. So the Koko can eat actually the pile. The max speed k can equals to 11. So this kind of the max, it could be probably be is gonna be whatever the max in our input array is. So for this case is 11. So for this case, it's going to be 11. So we start from k equals to 1. So if in this case, so k equals to 1, then the first pile, how many hours we need? It's going to be 3 by 1 plus 6 by 1 plus 7 by 1 plus 11 by 1. So it's total gonna be, the total gonna be greater than 8, right? And then when k equals to 2, it's gonna be 3 by 2 plus 6 by 2 plus 7 by 2 plus 11 by 2. So how many hours? So pay attention about here. So we are going to use the round up because see here, here shows that if the pile has less than k banana, she eats all of them instead and will not eat any more banana during this hour. And then each hour he chooses the banana and eats k from that pile. So for this one, 3 divided by 2 here, because we round up, it's going to be 2 plus 3 plus 4 plus 6. This one's still greater than 8. Okay, so we do this iterator, and then eventually we will find a k. In this case, it's 4 actually, you know. So, but the worst case, the k equals to 11. Okay, for this problem. So, for the time complexity for this problem, let's see the time complexity for this problem. So, so it's gonna be what, like so first we need to actually iterate we actually linearly to find the max value of the pile. So it's 11. So it's gonna be the max value. It's gonna be max value of p, okay, times p because kind of the max value is 11, right? So that means the k can be what? The k actually possibly could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So yeah, this is the probability. The k probably could be this one. Okay. So the maximum number of here is 11. We can linearly got this one. So, and then because we have to iterate every single speed to calculate, to compute the total hour. So when the speed equals 2, so how many hour we need? When it equals to 3, how many hour, right? So it's kind of like that. Okay. And then we can actually use another algorithm. We can use binary search. So in the binary search, instead of we linearly to find the kind of the 11 to I mean the iterator every single element in k, we can use binary search to do it. So the time complexity, it will be, instead of the max p, we can do log max p. Okay, so we can use binary search. So binary search. Okay, so what's binary search? Binary search is an algorithm that divides, so can divide the search space in 2 after every comparison. Okay, so and the binary search could be considered every time we need to search for an index or an element in an input array or in a collection, whatever. Okay, so let's give an example of this problem using binary search. What are gonna be? Okay, so here is the input, the piles. We have 4 piles here, so it's the 3, 6, 7, 11, and then ours is 8. Okay, so for this problem, like we just actually did that. So the k, the k, the k minimize 1. That's the minimum. It could be it could probably be for the k, because the Koko cannot eat like 0. 0 means nothing, right? So at least Koko can eat 1 banana every single hour. So k will equals to the maximum of p, the max of p. For this example, p, the max one is equals to 11, so we can linearly to find this one. Actually, it's 11. We can linearly find them this max. Okay. Okay, so yeah, probably it's like this. So that means the k gonna be like this. We just actually write it down. Let's just copy paste it here. So and then we do the binary search for the k element. Okay, so what we do, we start from here. So we start from here. This is L. This part is R. And then the middle is M. Okay, this is the middle is 6. So in this case, how many hours? We will calculate the hours we're gonna use to eat the bananas. So what we do, we 1 divided by, oh, sorry about that. Yeah, it should be here. So 3 divided by 6. Okay, so we're gonna round down. We're gonna round down this one. So 3 divided by 6, of course, is 1, right? And then 6 divided by 6 is gonna be 1, and 7 divided by 6 is gonna be 2. Okay, we round up, so it's gonna be 2, and 11 divided by 6 is gonna be 2. So total hour is how many? Here is 1. Okay, because we round out is 1, and it's 6. Total hour is 6. The 6 is smaller than 8. Okay, that means what? That means that within 6 hours, with the eating speed of 6, so per hour eat 6 banana, we can finish all the bananas in this example, right? So, but we are trying to retain the minimum integer k. That means Koko can eat banana slower than 6. So in this case, we update R to the middle point. Okay, so it's gonna be L. Here is gonna be R, and then here is middle, right? Here's middle, right? So 1, 2, 3, 4. Yeah, 3 is the middle. Okay, so for this problem, we can do m equals to 3. So 3 divided by 3 is 1, and 6 divided by 3 is 2. 7 divided by 3 is 3 because we are round out, and 11 divided by 3 is gonna be 4. So total hour is gonna be how many? 1, 3, 6, 10 hour. So the 10 hour is greater than 8. So what do we do? We will update. That means we can eat a little bit more faster than 3. Okay, so and then we update left to here, right still here, and then the middle 1, 2, 3, 4. So it's gonna be the 4. So it's gonna be here. The middle gonna be here. Yeah, the middle gonna be here. So the total hour, how many hours if we do here? So it's gonna be, let's check here, 3 by 4. 3 by 4. Okay, we round up. This one is gonna be 1. Okay, and 6 by 4 is gonna be 2. 7 by 4 is gonna be 2. 11 by 4 is gonna be 3. So total hour is gonna be 1, 3, 6, 8. It's gonna be 8 hour. Okay, this will and then we found it. So this hour. So when m equals to 4 is gonna be 8 hour, right? So yeah, we don't have to update anymore. So okay, the time complexity for this kind of for binary search. Okay, so as we said, we are searching K using binary search, not an iterator, right? Not using the brute force algorithm. So basically, it's gonna be log this part, log this part. Okay, so it's gonna be log max p and plus p. Yeah, this is a time complexity. Let's write in the code. Let's write the code. So for this problem, so first, so for this problem, the input, let's say, so the piles, so here piles, like we have 4 piles, 3, 6, 7, 11, and hours is 8 hour. Within 8 hour, the Koko will finish all the bananas with the minimum integer k, the minimum eating space of pet k. So that's basically the problem. And then the left equals to 1 because Koko eat at least 1 banana, right? So, we are searching from the k. We cannot equals to 0 here, right? So, and the right, so we initial the right equals to 0, but the right is going to be the max value. It could be, it could probably be whatever the maximum number of the piles. So for this case is 11. Let's looking for that one, right? So we can linearly to get the 11. So what we do, we just do this piles, and then what we do, we write equals to max dom max right pile. Okay, so this part of it, what we did, so this part of it linear time to find the max in input array. Yeah, this is what we do. And then we got the initial arrange k equals to this. Okay, so we got 11 actually. Yeah, we got 11 in this case. Okay, let's write the while loop. The searching condition is gonna be left plus 1 smaller than right. And then what we do, we do the middle equals to left plus right minus left by 2. Into hours equals to get hours. So we need to compute the hours. If we eat at a speed of k, how many hours the Koko can finish all the bananas, okay? So we will write a function how to calculate the get hours after the while loop, okay? It could be here. Private, the return type is gonna be int, get hours, because how many hours we are doing. So int piles, in the middle, because we are trying to search this, okay? So int hours equals to 0 at the beginning, and then we write a for loop. So int pile and piles here. What we do, the hours, so it's gonna be like this. The style, because we are trying to get we round up, right? So that's why we use the style here. So piles by mid. That's the speed we are choosing. We are choosing current speed of the middle, and then use the number of the pile like 3 divided by middle, 6 divided by middle, 7 divided by middle, and then we plus together, okay? And then, so we calculate the pile, and then we return the hours, okay? This get hours, okay? And then after we compute the hours, so let's check if the hours equals to, if the hour equals to h equals to the 8, right here in this case is 8. In here is h, is a small h, we put a small h here, right? So if it equals to 8, what do we do? Lowercase 8. So so if the total hours greater than 8, that means Koko eat too slow, so we need to faster, so we need to update our left to the middle point. Else what we do, here is gonna be update to the right, okay? Else we're gonna update the right. Okay, after the while loop then, so what we do, if get hours whiles left smaller equals to, with this one smaller equals to h. We return left, otherwise we return right. Okay, let's run the code. Okay, it's accept. Okay, the test case, let's try the second input also. Let's try this one. And it's 5. Let's run again. Okay, it's also accept. Let's try the third one. Okay, it works. Okay, the time complexity for this one is big O log n max p times p. Okay, let's submit. Let's try. Okay, we are faster than 21% of Java Online submitting for Koko eating banana. Okay, thank you for watching. I'll see you next time.